Hey everybody. So we are looking at 8.4 simplifying radical expressions. All right. And it's going to be mostly focused on a specific type of radicals, square roots, which are probably the ones you're most familiar with. All right. So go ahead and get this title here, and then I'll scroll up and let you get the rules for square roots. Okay, so basically here are the rules for square roots here, and we'll be going over just I think the first two of them in this lesson. Actually, maybe just the first one here, and then we'll get into some of the others in following lessons. Okay, but we'll look at them all right now real quick. Okay, so basically this whole lesson is about simplifying square roots. Okay, and it says a square root is in its simplest form if the first thing no perfect square factors are left in the radicand. All right, so I guess first thing, some of the words. Okay, we have the radical sign, which would be just this square root symbol here, and then the radicand is whatever is in the radical. Okay, so the 9 would be considered the radicand. Okay, so basically you're saying no perfect square factors are left in the radicand. Okay, right here, 9 would be considered a perfect square factor because you guys probably memorized the square root of 9 is just a nice clean 3. All right, so when that's the case, we can't have any of those. And really, that is the focus of this lesson. Okay, the other two, we'll just kind of skim over real quick, but it says the other thing is no fractions are in the radicand. We cannot have fractions underneath the radical sign. Okay, and then the other thing is no radicals appear in the denominator of a fraction. We cannot have radicals in the denominator. Okay, but today, really, this lesson is all about this first rule, and we're going to be going over a lot of examples because there's actually a lot to take from this. Okay, so let's jump into it. Okay, so first thing, we're going to just try out three simple-looking radicals and simplify them. Okay, go ahead and get these, and we'll do it together. Okay, so first thing to know, these are not perfect squares. These are not radicals like the square root of 25, which most people memorize and go, oh, it's 5. Okay, but just by the way, let's start with that. Okay, you don't need to write this necessarily, but if I wanted to simplify the square root of 25, say I didn't know, say I hadn't memorized that the square root of 25 is 5. Okay, here's what I could do. I could break it down into its factors. Okay, and by factors, or I guess more specifically, it's prime factors. That's what are the numbers that multiply to get a 25? Okay, well, the two numbers that come to mind for me is 5 times 5, right? Okay, and these fives are prime, meaning they cannot be broken down anymore into two other numbers. All right, and the idea is when we break down these radicals into their prime numbers, pairs of numbers are going to come out of the radical. So this pair of fives means a 5 would come out of the radical, and we'd have our answer. Okay, so that is really the idea, and that's what we're going to do here. So let's try that with 24. Okay, let's go ahead and break it down. Okay, we're just thinking of two numbers that multiply to get 24, and oftentimes there's options. We could do 2 times 12. We could do what else? 8 times 3. There's options. Do whatever comes to mind first. I'm going to do 2 times 12. Okay, here's my first piece of advice. Put the smaller number on the left and the bigger number on the right. It makes it so as you break down your numbers, they're ordered in a nice way. Okay, so 2 is prime. We cannot break it down anymore. 12 is not, though. We can. All right, the first thing that comes to mind for me when breaking down 12 is a 2 times 6. Okay, when you break a number down, cross it out. That 12 does not exist anymore. It's now a 2 times 6. Okay, 2 is prime, 6 isn't. We can break it down into a 2 times 3, cross it out. Okay, and 2 is prime and 3 is prime. So what we just did is we broke down 24 into its prime factors. If we were to multiply 2 times 2 times 2 times 3, we would get 24. Okay, so again, why did we do this? Well, here's the idea. Pairs of numbers, just like this pair of 5s meant a 5 came out, same idea with this one. This pair of 2s means that a 2 is going to come out of the radicand. Okay, or out of the radical, excuse me. Okay, I'm looking for any other pairs of numbers, pairs of the same number, and I see that, no, we do not have another 2 to pair with this. We don't have another 3 to pair with these. So what I like to do is I like to underline the things that don't pair up. And what that means is that those are going to stay inside of the radical. Okay, so inside of the radical, we have a 2 and a 3, and everything's always being multiplied together. Okay, so I kind of didn't leave myself a ton of room here, but you might have left yourself a little bit more room. Okay, last thing is just to kind of multiply what we have here, and I'm going to get a 2 square root of 6. Okay, and there it is. That's the simplified form of the square root of 24. These literally represent the same number. If you were to type both of these in a calculator, you'd get the same decimal. Okay, but today we're not doing decimals, we're simplifying. All right, and this is the process right here. If you wrap your brain around this, that's a lot of these problems, at least at the beginning here. Okay, so let's do a couple more examples real quick, and then I'll have you guys try some on your own. So let's simplify the square root of 32. Okay, so first thing I'm thinking is, two numbers that multiply to get 32. Again, there are options, all right? The first one that comes to my mind is a 2 times a 16. Okay, often when it's even, I often think, okay, I know I can take half of that. Half of 32 is 16. That's what I often do if I have an even number. Okay, but there are other options. You could have done 4 times 8, or there's others. Okay, so 2 is prime again. It doesn't need to be broken down. 16 isn't. I'm going to break it down. Okay, I could do 2 times 8. I could do 4 times 4. Just to make a point, I'm going to do 4 times 4. Okay, and I'm going to cross out 16. I broke it down. Okay, here I have two numbers that are not prime. So I'm going to go ahead and break both of them down. 4 is a 2 times 2, cross it out. This 4 is another 2 times 2, cross it out. Okay, so again, I broke this down into its prime factors, a bunch of 2's, it just so happens. So what I'm looking for are pairs of the same number to take out. All right, and I can pair them. I can say this is a pair, or if I wanted to circle these as pairs, however you want to pair them up is fine. I'm going to do these because they're right next to one another. All right, and this 2 up here does not pair up. Okay, so just a reminder, this pair of 2's right here means a single 2 comes out. This other pair of 2's means another 2 comes out. Again, they're always being multiplied together. Sorry, that's supposed to be a multiplication sign. Okay, what doesn't pair up stays in the radical. That's this 2. Okay, so on this one, it just so happens we have numbers multiplying on the outside. If I were to do that, I'm going to get a 4 square root of 2. And there is the simplified form of the square root of 32. Okay, let's try this last one here, 30. So again, I'm going to break it down thinking of two numbers that multiply to get 30. The first thing that comes to mind for me is a 2 times 15. Okay, again, I could have done 3 times 10. I could have done 5 times 6. Whatever comes to mind first, you can do. It doesn't matter. Okay, 2 is prime, 15 isn't. And let's break it down. 15 is 3 times 5. Okay, cross it out. Okay, 3 is prime and 5 is prime. So what I did is I broke this thing down into its prime factors just like before, and I'm thinking, do I have any pairs of numbers to pull out of the radical? Well, if you guys notice on this one, I do not. 2, there's not a 2 to pair it up with. 3, 5, there's no pairs. What this means is all of these are staying in the radical. Okay, and if I were to write it out the long way, I would get 2 times 3 times 5. Okay, which when I multiply those together, I would get the square root of 30. Okay, so that's a long way of saying the square root of 30 is already as simplified as possible. Okay, so the point of this one is to realize sometimes these radicals, they cannot be broken down. They cannot be simplified anymore. All right, it really just depends. All right, so yeah, that's this problem here. It stays a square root of 30. In other words, if I were to do this normally and I would notice, oh, these are broken down, nothing's coming out, I would just jump to the case and I would say, okay, well, that means the square root of 30 is staying the square root of 30. That's what I would do normally. But in your notes, show yourself that, they all stay inside and it stays the same. Okay, cool. So I'm gonna have you guys try out a couple of these. Go ahead and simplify the square root of 48 and 60. Try it out. Okay, so when I go to break this down, again, it's even. I'm thinking 2 times half of 48, which is 24. That's what I'm going to start with. You might have used different numbers, but that's fine. We'll eventually break them down into the same numbers. Okay, 24, I'm thinking 2 times 12, cross it out. Okay, 2's prime, 12, 2 times 6, cross it out. 2's prime, 6 isn't, 2 times 3, cross it out. Okay, so here's all my prime factors of 48. I'm looking for pairs. Pair of 2's there, pair of 2's there, and this 3 does not pair up. Okay, so again, what this means is this pair of 2's means a 2 comes out. This pair of 2's means another 2 comes out. And this 3 that does not pair up means it stays inside the radical. Okay, and then last thing, multiplying these for square root of 3. Okay, on number 2, let's see, for me, the first thing that comes to mind is a 6 times 10. Okay, so I know 6 is not prime. I can break it down into a 2 times 3, cross it out. 10, same thing, not prime. I can break it down 2 times 5, cross it out. Okay, and it looks like, yep, these are all prime numbers. Okay, here's the thing, the pair of 2's, unlike these, they're not next to one another, but that's fine. What I normally do, if they're not side by side, I'll circle both of them and maybe kind of connect them just to show, okay, there's my pair of 2's. Okay, but the 3 doesn't pair up, the 5 doesn't pair up, they stay inside. So a pair of 2's means a 2 comes out. Inside the radical is a 3 times 5. Okay, so it looks like the simplified form of square root of 60 is a 2 square root of 15. Okay, so when it comes to simplifying radicals, that is the process right there. It's really not that bad. Don't be intimidated because, square roots are scary. Break them down, look for pairs. That's it. Okay, so from here, what happens when they introduce, variables into a radical? Okay, copy this, we'll do it together. Okay, so, what happens is, nothing really changes. We're still gonna break this down. Okay, start with the number here. 9, I know can break down into a 3 times 3. Okay, those are prime, they're good. Before I pair up numbers, I'm gonna break everything down. Okay, x to the power of 5, we know is x multiplied by itself 5 times, right? So the way I like to represent this is just showing that this is, 5 x's. Okay, that's x to the power of 5. All right, now that I've broken everything down, let's look for pairs. Okay, I have a pair of 3's, pair of x's, another pair of x's. This x, though, does not pair up. That one's going to stay inside. All right, so here's my answer sitting in front of me. Pair of 3's means a single 3 comes out. This pair of x's means an x comes out. This pair of x's means another x comes out. What stays inside is this x. Okay, but don't forget, multiply what you can. X times x is x squared. Okay, so my best looking answer is a 3x squared square root of x. Okay, the answer, it looks scary, it looks, weird, but the process is really simple, right? So again, don't be intimidated by these. Okay, so with that in mind, go ahead and simplify these 2 problems right here. Okay, so on this first one, I know 25 breaks down into a 5 times 5. These 5's are prime, so can't go any farther on this. An x squared is an x, or I guess rather 2 x's. Okay, so again, we're looking for pairs. Looks like we have a pair of 5's, looks like we have a pair of x's, and there is nothing that doesn't pair up. Okay, so on this problem, pair of 5's means a 5 comes out, pair of x's means an x comes out, but there is nothing left in the radical, meaning we do not need to write it. We don't need to write square root or anything like that, all right? And this is our answer, okay? So actually, this right here is a perfect square. Okay, and what that means is when we simplify it, there is no square root left over. We get a nice clean answer. So, just something to know. Okay, on number 28, breaking down 28, I first think, 2 times 14. 2 is prime. 14 can be broken down into 2 times 7. Cross it out. 2 is prime and 7 is prime, right? We can't break that down any farther. Okay, m to the power of 5 is 5 m's. So let's go ahead and write them out. Okay, so again, looking for pairs. There's a pair of 2's. Okay, the 7, there is no other 7, so it stays inside. Pair of m's, that m stays inside. All right, so starting with what comes out. Pair of 2's means a 2 comes out. Pair of m's, I mean, really, if we want to cut to the chase, this pair of m's, this means 1 comes out, this means another comes out. So I'm going to end up with an m squared if we just want to, know that's going to happen. Inside of my radical, again, if we just want to kind of cut to the chase, I know we have a 7 and an m left inside, so 7m. Okay, and yeah, there's no other, I can't do any more multiplication here, so I know that I'm done. Okay, weird looking answer, easy process. Okay, so let's keep moving along. We're going to try some. What happens when we have multiple radicals, being multiplied together? Okay, go ahead and get both of these. We'll do together. Okay, so here's the thing. We could multiply these radicals together. We could do a 50 times 18, which, by the way, let me just type it in. Okay, which would give me 900. Okay, and we would get the square root of 900. But here's the thing: we would then need to break down the square root of 900. Okay, and if we did that, the square root of 900, we could break it into a 50 times an 18. Okay, so the point I'm trying to make is when you have this sort of problem, don't multiply the radicals, just break them down. Okay, break them down individually. That's what we would do right here, right? We'd break down a 50, we'd break down an 18. That's exactly what we're going to do. We're going to break down a 50 and we're going to break down the 18. And then we're going to eventually look for pairs of numbers. All right. So yeah, when you see multiplication on these, usually the easiest thing to do is just don't multiply, break them down. Okay, so 50, I'm thinking 5 times 10. 5 is prime. 10 can be broken down into 2 times 5. Cross it out. 18, I'm thinking 2 times 9. 2 is prime. 9 broken down into 3 times 3. Cross it out. Okay, so here is everything I've broken up. Okay, when I go to pair up numbers, I can pair up numbers from, both sides. Okay, so first thing I notice is I have a pair of 5s right here. Okay, maybe I'll show that they're pairing up with that little line. Okay, I also notice I have a pair of 2s, even though they're, separated, they're technically not. This is all the same problem because it's multiplication. So that pair of 2s pairs together. Okay, you don't necessarily have to do these lines connecting them, but I like to show it visually. Okay, and then this pair of 3s, same idea. Okay, those pair up. So it looks like on this problem, everything is pairing up. All right, so what comes out of the radical? Pair of 5s means a 5 comes out, a 2 comes out, and a 3 comes out. Okay, and then multiplying this together, 5 times 2 is 10, 10 times 3 is 30. Okay, so yeah, there it is. Just so happens this was a perfect square. Remember, that just means that we get rid of the radical and we simplify it. Okay, taking a look at number 2. On this one, we have a 5 times 30. Again, but I'm not going to multiply these. I'm going to break them down individually. But here's something interesting. This square root of 5, 5 is prime. I cannot break it down anymore. Okay, so, but it is part of the numbers I'm going to try to pair up. So I do need to bring it down. Okay, 30, I can break down. I'm thinking, what, 5 times 6 we can do? Okay, 5 is prime. 6, though, can be broken down to a 2 times 3. Cross it out. Okay, so I'm looking for pairs. Looks like I have a pair of 5s. A 5 is going to come out. 2 and 3 stays inside. Okay, so it looks like this is going to turn into a 5 square root of 2 times 3. Okay, going one more step, multiplying those, 5 square root of 6. Okay, so when you see multiplication, it really doesn't change the way you do these problems. You just have a little bit more to break down. Okay, so I'm gonna have you guys go ahead and try this one out on your own, and then we'll keep moving. Okay, so just like before, this square root of 2, 2 is prime. It cannot be broken down, but it is part of the numbers we're trying to pair up. So I'm gonna bring it down. 20, I think 2 times 10. Okay, 2 is prime. 10 can be broken down into 2 times 5. Cross it out. Okay, and now we have a bunch of prime numbers. All right, I just want to point out, I could pair up these two, or I could pair up these two. It really doesn't matter. Normally, if they're side by side, I like to pair them up just because it's easier to circle them. Okay, so there's a pair of 2s. This 2 doesn't have another 2. This 5 doesn't have another 5, so they stay inside the radical. So it looks like this is turning into a 2 square root of 2 times 5. If we want to, cut to the chase, we can just go ahead and multiply those and know we're getting a 10. Okay, so yeah, we have just a couple more types of problems to look at. Let's look at these ones where they're multiplying, but they're throwing variables in. Go ahead and copy this. We'll try it out. Okay, so not a whole lot more happens here. We're just breaking down more things. So this 14 breaks down into a 2 times 7. Those are both prime. This x, let's just show that that's part of, what we're going to be trying to pair up. This 2 is prime, but we're going to try to pair it up. X squared is 2x's. Okay, so we broke it all down. Now I'm looking for pairs. Looks like we have a pair of 2s. 7 doesn't pair up. Okay, we have a pair of x's, but I'm going to circle these ones over here since they're next to one another. This x does not pair up. Okay, so not a whole lot different from the other problems. We just had some variables. Okay, but yeah, pair of 2's means a 2 comes out. Pair of x's means an x comes out. What doesn't pair up, 7 and x stays inside. Okay, and just by the way, when you write these problems, get used to writing the number and then the variable, and then inside the radical, same thing, number and the variable. Okay, so yeah, nothing too different. Okay, so I'm going to have you guys try one of these on your own, and then I think we have one more type of problem. Okay, so this 3 is prime, but we need to bring it down. B cubed is 3b's. Okay, 18, I think in 2 times 9. 9 can be broken down into 3 times 3, and then there's a single b here. Okay, so looking for pairs. I know this 3 can pair up with one of these 3's, but I'm going to just pair these together. Okay, there's not another 3, there's not another 2. Pair of b's, we have a pair there, and we actually have a pair here. Be careful, be easy to think that we don't, but yeah, we do. This b and this b. If you want to connect them with a line, I don't know, it gets a little like kind of crazy if you do it, but I'm going to do it anyway. Okay, so what's coming out? Starting with my numbers, always start with your numbers. Pair of 3's means a 3 comes out. This pair of b's means one b comes out. This other pair of b's means another b comes out. So I'm just going to go ahead and write it as b squared. What stays in the radical is what didn't pair, which is this 2 and this 3, which I know is going to multiply to give me a 6. So I'm just going to go ahead and write it. Okay, I'm skipping that initial step. If it helps, guys, to write in your notes that, okay, we had a 3, a b, and a b. Inside of here, we had a 2 times 3. If you want to show this first step and then show that this is the final answer, that's perfectly fine. I'm just wanting you to know if you can do some of this in your head and get to your answer, that's also fine with me. Okay, but it's not a bad idea in your notes to maybe show this as well. All right, so last type of problem. What do we do when we have a lot going on? What happens when we have a number already on the outside of a radical? Okay, copy this and we'll do it. Okay, so first things first. The only new part here is this number on the outside of the radical. Okay, here's the good news. There's really nothing to worry about with it. If the 2 is already on the outside of a radical, I know it's going to be already on the outside when I go to write my answer. So that's always the first thing I would do is if you ever see numbers on the outside, just go ahead and start writing your answer. This 2, it's on the outside of the radical. Okay, from here, we can break this stuff down. All right, so yeah, we have 2 m's. So 2 m's, 1 n. We have a 9 that breaks down into a 3 times 3. And we have an n cubed that breaks down into 3 n's. Okay, so what are we pairing up? Looks like we have a pair of m's. Actually, I guess normally I would start with my numbers. We have a pair of 3's. Okay, but yeah, from there, a pair of m's. We have a pair of n's here, and we have another pair of n's. Okay, so it looks like actually everything here is pairing up. Everything is coming out of the radical. All right, so let's start with our number. We have a 3 coming out. It's being multiplied. Okay, and inside, or actually, no, there's nothing left inside. We have a pair of m's, means an m comes out. And we have 2 pair of n's, so that means 2 n's come out. Okay, if you wanted to just straight up write that as an n squared, that'd be fine. But I'm going to go one more step and go ahead and multiply this together. We got a 6mn squared. All right. So yeah, this right here, this looks scary, right? This is like really intimidating. It's a really simple process. So please don't overcomplicate this stuff. Okay, cool. So last one, try this out on your own. Okay, so first thing I hope you did is realize, all right, we got a 3 on the outside. Let's go ahead and write that. That's part of my answer. All right, from here, let's break down this 40. The first thing that comes to mind for me is a 2 times 20. Okay, 2 is prime, 20, 2 times 10, cross it out. 2 is prime, 10, 2 times 5, cross it out. Okay, so there we go, a bunch of prime numbers. We'll get to that. We have an x, we have 2 y's. Over on this one, we have a 2 and 3 x's. Okay, so breaking it down, nothing too crazy. Let's look for our pairs of numbers and variables. Okay, so I got a pair of twos. Okay, be careful, it'll be easy to miss this, but we have another pair of twos, right? So this two and this two, if you want to show that they're connected. Okay, this five, I don't see any other fives, it's staying inside. Okay, this X is going to pair up with this X. Okay, okay, another pair of X's right here, another pair of Y's. All right, so it's always, this is why we do the circling and the underlining, because when problems get this complicated, it's really easy to forget some stuff. So the circling and the underlining really helps to, have you scan through and see, did I miss anything? No, everything has, either a circle or a line underneath it. So we know we're good to start getting our answer. Okay, so starting with the numbers, pair of twos means a two comes out. Another pair of twos means another two comes out. Okay, we always, when we deal with variables, we want to deal with them alphabetically. So let's first start with our x's. Okay, we have this pair of x's and x. We have another pair of x's. Okay, we have a pair of y's. Okay, and I'm looking through, it looks like the only thing that's staying in the radical is this 5. So don't forget square root of 5 here. Okay, so finally, there's a lot going on here, but let's multiply. 3 times 2 is 6. 6 times 2 gives me a 12. 2x's is an x squared. Y, square root of 5. Okay, so yeah, that is simplifying radicals. Hopefully you feel comfortable with it now and realize, yeah, this is not really that bad of a process. I can do this. Okay, we'll eventually get into the other rules that we're dealing with, having fractions in the radicand or on the denominator of a fraction. Okay, but yeah, for now, that's that, guys. I'll see you.